I'm now going to discuss each of these 11 hypothalamic nuclei. First and foremost, if you can remember previously, I said that in the preoptic area, we have only one nucleus, and that nucleus is called preoptic nucleus. This preoptic nucleus is responsible for the production of what you call gonadotropin releasing hormone. So it's responsible for our growth. Are you clear? And similarly, it is the same hormone that gives us our sexual dimorphism. That means to be a man or to be a woman. Are you clear? So it is the one that gives our sexual differences. In the case of female, growth of the breast, growth of the hips, and fatty tissues in the body, you get it? And somehow a voice different from that of a man. And in men, you know, we have our development of male characteristics, whereby we have beard if we are matured, and some hair here and there, and with the strong muscles and what have you. Are you clear? So it is all this hormone that is now giving us that characteristic because of the hormone it releases that act directly on the anterior pituitary gland. Are you clear? Similarly, it has been postulated that this same preoptic nucleus is also responsible for our sexual orientation. Sexual orientation in the sense that one may be what we call heterosexual or homosexual. You get my point? So homosexuality is also part of the function of this preoptic nucleus. So that means somebody who is heterosexual or homosexual, it is also as a result of this function of this, preoptic nucleus. Are you clear? Good. So we have now seen this preoptic nucleus responsible for our sexual dimorphism, and also responsible for our sexual orientation. Are you clear? Good. So we now take the suprachiasmatic nucleus. The suprachiasmatic nucleus is a very important nucleus in that it is responsible for our what we call circadian rhythm. It is responsible for what? Circadian rhythm. So this circadian rhythm is responsible for our, wakefulness and sleeping cycle. Are you clear? What we call this suprachiasmatic nucleus, we call it our biological clock. You get my point? So it's like this biological clock or suprachiasmatic nucleus has connection with the hypothalamus that we have discussed before. If you can remember, we discussed about the two thalami. At the back of the two thalami, I discussed about the habenular nuclei. Are you clear? And so we said the two habenular nuclei, they are connected by habenular commissure. Are you clear? And so this, at the back of this habenular commissure, we have attached to this our pineal gland. If you can remember, we talked about the pineal gland, where we said that previously scientists believed that was the center of soul. And then the researchers went ahead to test whether it is true or not. You get my point? And it was discovered that that was not the area where the soul is located. Are you clear? So what happens is that the pineal gland, this pineal gland, produces about 3 hormones. What we call 5-hydroxytryptamine in your biochemistry. Also melatonin, not melanin, melatonin, and also what we call cholecystokinin, pancreozymin. Are you clear in biochemistry? So this pineal gland produces these three hormones. The 5-hydroxytryptamine is what we call serotonin. Serotonin. This serotonin is responsible for making us awake as we are now. So the amount of serotonin in our own circulation is what is making us awake. Are you clear? And if its amount reduces, the amount of melatonin increases. So they go hand in hand. If this one falls, the other one rises. Are you clear? So in the daytime, when we are not sleeping, because of the sunlight, the amount of serotonin now increases, and this decreases. How does this happen? What is going on is that during the daytime, you have sunlight coming and passing into our eyes. Are you clear? From the two eyes. Are you clear? This sunlight, as it enters into this, passes through the optic chiasma, right? From there now, this sunlight, there are some connection between the optic chiasma and the suprachiasmatic nucleus. These fibers, are you clear? They take information from this optic chiasma and take it to the suprachiasmatic nucleus. Are you clear? So that any light that passes into our eye or eyes, it will now go to the optic chiasma. From there, pass through this connection between the optic chiasma and the suprachiasmatic nucleus. Are you clear? This connection is what we call retinochiasmatic. Retino what? Chiasmatic tract. You get it? So we have retinochiasmatic tract connecting the optic chiasma with the suprachiasmatic nucleus. So much so that by the time this light is taken to this, are you clear? This suprachiasmatic nucleus has a very long connection with it and the pineal gland. Are you clear? So that as soon as the light stimulus hits this suprachiasmatic nucleus, the information is taken to the pineal gland so that the light will now act on the pineal gland to secrete more serotonin. Are you clear? But by the time we are approaching evening time, when the amount of light is reduced, you get my point? So this information is still being taken by this suprachiasmatic nucleus back into the pineal gland. So because the amount of information for light is low, then serotonin is no longer produced in large amount. You get my point? So what will happen? Melatonin will shoot up. Are you clear? So that you start feeling tired, you start feeling going to bed. Are you clear? And that is why actually in our religion, that Prophet said, if you want to sleep, we off the light. Have you seen the wisdom?
Yes, sir.
Yes, so that to increase the level of melatonin for you to be able to sleep. That is the wisdom behind that. So we have now seen the function of this suprachiasmatic nucleus. The next nucleus is what we call anterior hypothalamic nucleus. Anterior hypothalamic nucleus is just like an air conditioner in that it is responsible for the regulation of our body temperature. Take for example now, this is cold weather season now. So it's like the atmosphere, especially early in the morning, the temperature probably is below 20 or at times below even 15 degrees centigrade. And so, our own body processes, the metabolism and what have you, they cannot work a single 1 degree centigrade fall. If it falls just a degree fall like that, because our normal body temperature is about 36.5 to 37, for example. So if you have anything less than that, the body process is not going to work fine. And so if the temperature in our environment reduces during this cold weather, for example, so ideally our own body temperature, internal body temperature, will also fall because there has to be a balance between the two. So luckily, this anterior hypothalamus, it is what we call anti-rise in temperature. That means the temperature, for example, now, if the temperature is high, now I said when the temperature is low during cold weather. So the physical function of this is to prevent the internal body temperature from rising up. So much so that during hot weather, if the temperature is hot, maybe 40 degrees centigrade or 50 degrees centigrade, ideally our internal body temperature should also rise so that it will reach about 40 or 40 something. But if it rises above that 37 or whatever, our body mechanism will not work well. So the anterior hypothalamic nucleus will now prevent the internal temperature to rise. Are you clear? And during cold weather, the posterior hypothalamic nucleus will act on the other way around. So like now, what is functioning is our posterior hypothalamic nucleus. That is the antifall nucleus. So this one prevent the falling down of our internal temperature, like during the cold weather now. The temperature is low in our environment, and so our internal body temperature should ideally fall down. But the posterior hypothalamic nucleus prevent, the temperature from falling down. Are you clear? Good. So the anterior hypothalamic nucleus now acts during hot season to prevent the rise in our body temperature. This is part of the autonomic nervous system function of the hypothalamus, because the two nuclei, both the posterior hypothalamic nucleus and the anterior hypothalamic nucleus, they all have connection with sympathetic and parasympathetic nerves of our body, which we'll discuss later on. Are you clear? So we said that both the anterior and posterior hypothalamic nucleus, they have connections with our sympathetic and parasympathetic nervous system. Are you clear? Yes. So now we've seen that. So the other hormone is what we call supraoptic nucleus. The supraoptic nucleus is responsible for the release of one hormone, what we call antidiuretic hormone. This antidiuretic hormone prevents diuresis. What do you mean by diuresis? What is meant by diuresis is like you pass excessive urine. For example, now you drink too much water, ideally you're expected to, pass large volume of urine. So the antidiuretic hormone prevents, diuresis. For example, now, if during fasting period, for those of us that do fast, we don't drink water, right? So since we don't drink water, the osmolality of our blood rises, right? Because the concentration of the solids inside the blood, is higher because there is no much water inside the blood. So the osmolality is, high. Are you clear? So if the osmolality is high, this nucleus senses the osmolality of the blood because, every part of the brain is being supplied by blood. So if the osmolality now increases in the blood circulation, this SON, this preoptic nucleus, will now sense the osmolality, and so it will now, it will release the hormone, so that once it releases the hormone, that antidiuretic hormone, so that much urine is not going to be excreted, so that you conserve water, so that the blood is going to be diluted more. Are you clear? The blood concentration now, osmolality is high, so the best thing is to decrease the osmolality by conserving water. So the nucleus will now release that hormone, and the hormone will now act on the distal convoluted tubule of the kidney, so that water is going to be reabsorbed from the distal convoluted tubule of the kidney, so that more water is found inside circulation, so that the osmolality is going to be diluted, so that you are not going to fall into, problems of this high osmolality of our blood. Are you all clear? Good. So we have now seen this. The other one is what we call paraventricular nucleus of the hypothalamus. This paraventricular nucleus of the hypothalamus secretes two hormones, what we call oxytocin and corticotropin releasing factor. Are you clear? So the oxytocin is responsible for, uterine contraction during labor. When women now get pregnant, when the pregnancy reaches 9 months, so there is a stimulus that stimulates this hormone, the paraventricular hormone. It releases more of the oxytocin that has now been taken through the circulation and get through there, reach the posterior part of the pituitary gland and get stored there. So the oxytocin now acts on the uterus so that it contracts during delivery. And similarly, the oxytocin also acts on the breast, so that at the end of the day, the breast will now contract during lactation. So I think we have a break, and then we come back, then we continue from where we stop.